Evening, everyone. So we're going to talk about equations of tangents and normals. So the situation is, we've learned how to find the gradient function, which is the gradient of the curve at any point. So if we just had a particular function here, it doesn't really matter what it is, just looks like that. And if I wanted to find the instantaneous rate of change at this point, P, the point is that I would need to find its gradient of the curve, which actually means the gradient of the tangent. Now we do that by differentiating, and then you substitute the point. You've got x and y, in there, so you'd substitute the point for x, and this curve is y equals f of x, some kind of function, and you'd substitute that point for x, and you'd be able to find the gradient. Now, the fact that you have the point x and y, and then you can find the gradient, means that you can then find the equation of the line. So it's using the point gradient formula. So using the point gradient formula, we can find the equation of the tangent. Now I'm going to add in a new word here, and normal. Now the normal is simply the line which I'll draw in pink. The normal is the line which is perpendicular going through that point. Now remember that if we want to find a perpendicular gradient, it's just the perpendicular gradient. Two gradients have to multiply to -1. The negative reciprocal is what we have. So we might as well go jump in and find a few examples. So basically the steps are, if I was to do questions like this, there's always exceptions. You need to think about each case, but steps are, we differentiate. So we sub in x coordinate to find gradient. Then use the point and gradient to find equation. Okay, let's give it a go. Example, I'm going to do 3 examples. Now, I'm not going to spend a lot of time on the differentiation, because the differentiation you need to be clear from before. So if you're not sure about steps in the differentiation, you need to go back to those sections and have a look, or ask me in class. So let's say we've got this function, y is equal to x squared plus 2 on x. Okay. So we want to find the equation of the tangent at x equals 1. All right? So for this curve, we want to find the equation of the tangent when x is equal to 1. So let's rewrite this. I'm going to use negative indices, x squared plus, this 2 on x is 2 times x to the -1. Now the first thing to note is, you notice I'm only being given an x coordinate. Some questions might give you x and y, but I've only been given an x. So when x is equal to 1, y is equal to 1 squared plus 2 times 1 to the -1. Well, that's just equal to 1 plus 2, which is equal to 3. Therefore, the point is, the coordinates are 1, 3. All right? So that's what we have. Coordinate has points 1, 3. Now, the next step is to say, okay, well, we need to find the gradient. So find the gradient at x equals 1. So therefore, we differentiate. So to differentiate, I'm going to have dy dx is equal to 2x minus 2 to the power of x to the -2. All right, which is equal to 2x minus 2 over x squared is what it becomes. So when x is equal to 1, the gradient m is equal to 2 times 1 minus 2 over 1, which is equal to 0. Now here we've found actually an interesting case where we found a point which has a horizontal gradient for this particular curve. We can still find the equation of that line though, so that's what we're going to do. So if I find a line, so using m equals 0 and 1, 3. Y minus 3 is equal to m, 0 times x minus 1. Obviously the right hand side is 0, so we just end up with y equals 3, which is a horizontal line. And there's our first question done. Okay, let's try one more and see how we go with it. Okay, let's try this one. Find the normal to the curve y equals 2x plus 5 over x minus 2, oh dear, x minus 2, my battery's going down, at 1 minus 5. Better hurry up here. Okay, so here, notice difference from the question, a couple of things. We're finding the normal, which is the perpendicular line to the tangent, and we've been given the x and y coordinates, so I don't have to sub in 1 and find that it's y and all that kind of stuff. All right, so we don't need to do that. Okay, so we're going to kind of go ahead and do this. Oh, sorry, I've made a mistake here. I've made a mistake. It is 2x plus 3. Oh, the wrong charger. Okay, so we've got find the normal to the curve. So I don't need to find the coordinates, so we're going to just find the gradient at x equals 1, so we need to differentiate. We're going to differentiate here. So let's do that. I'm just plugging in to make sure I don't run out. So if we differentiate, what are we going to need to use? Well, we need to use the quotient rule, right? So we've got 2x plus 3 over x minus 2. So u is equal to 2x plus 3. U dash is equal to 2, the derivative of that. V is equal to x minus 2. V dash is just equal to 1. So dy dx is equal to v u dash. So u dash times v, you could think about it, 2 times x minus 2, minus u v dash. V dash is 1, so I don't need to write it. Take care with the negative, I'm going to keep it in brackets, over v squared. All right, I'm just going to simplify this, but because I'm just finding I'm finding the gradient as a number, like a quantity, rather than finding an expression for the gradient. I don't particularly need to spend a huge amount of time making it a really nice looking expressions, but it's easier to sub in if I have less things to work with. So that's going to go away, that's going to go away. Minus 7 over x minus 2 all squared. So when x is equal to 1, we're going to have m, now I'm going to call this m of tangent, equals minus 7 over 1 minus 2 all squared. Now that's just going to be equal to minus 7. So therefore the gradient of the normal is equal to 1 on 7, the negative reciprocal of negative 7. So using m of the normal equals 1/7 and the point 1 minus 5, we have y minus 5, so y plus 5 is equal to 1/7 bracket x minus 1. That's the point gradient formula. Y minus y1 equals m x minus x1. If I multiply everything by 7, we get 7y plus 35 equals x minus 1. Move everything over to the right, we get x minus 7y minus 36. And there is in general form. Happy days. Okay, I want to try one more example. Just one more example, which is the following. There's a couple of variations, and I don't want to do every single type of variation because you need to use all the tools like chain rule, quotient rule, product rule, but also different types of methods to solve questions you might encounter. So it's not always super straightforward, right? You want to be thinking, well, how do I kind of mix things up and make sure that I'm not just doing the same thing? So let me take this question. Find any value of p if the tangent to the curve y equals px squared minus 6x minus 3 is parallel to the line 5x minus 3y plus 2 equals 0 at the point where x equals minus 3. All right, so find any value of p if the tangent to the curve y equals px squared minus 6x minus 3 is parallel to the line 5x minus 3y plus 2. So here we've got an unknown part of our expression. This is p. And we need to do a couple of things to make sure that whatever the gradient I end up with matches up with the gradient of this line. So that's the first thing to ask. So gradient of line, let's call it ML. Now that's equal to, remember we said it's negative A on B. So if I rearrange this line to gradient intercept form, this will become 5x plus 2 equals 3y. Divide by 3, you get y equals 5 on 3x plus 2 on 3. So therefore the m of the line is equal to 5 over 3, negative A on B. Okay, so therefore, when we differentiate the curve and sub in x equals minus 3, it has to equal m equals 5 on 3. That's what the question's saying. The tangent at the point x equals minus 3 for this function, where I don't know what p is, I'm about to find it, has to be 5 on 3 because it's parallel. The gradient's going to be the same as this line. So if we find dy dx, that's going to be 2px minus 6. All right. Now, when x equals minus 3, what I just said was m is equal to 5 on 3. Therefore, 2p times minus 3 minus 6 has to equal 5 on 3. And this is now an equation in p which we solve. Minus 6p minus 6 equals 5 on 3. We add the 6, so that's going to become, well, minus 6 is 18 on 3. So that's going to be 23 on 3, and p is equal to negative 23 on 18. And that's the value. That's the value. Now it says values, but I'm pretty sure that we can only have one of those for which that's going to be the case. All right? So that's kind of the way that we need to approach that type of question. So we're coming to the end of our little exercise, exercise 8.8. See how you go.